In section 2.6, we learn about continuity. There are several different types of continuity, and the first type of continuity I want to discuss is what is called continuity at a point. Basically, the layman's terms of what continuity means is that can you draw the graph of the function without lifting your pencil off the paper? We will come up with a formal definition after we discuss this. So I want to know, we look at this function, f of x equals x squared minus 1 over x minus 1, and we see that the graph is, I can draw it without lifting my pencil off the paper at every point except for when x equals 1. So what we can say is that f of x is discontinuous at x equals 1, and then we have to give a reason. Well, the reason why it's discontinuous is because f of 1 does not exist. Or another way, f of 1 is undefined. So before we can define the formal definition of continuity, we're going to figure out what makes a function discontinuous, and from that be able to come up with our definition of continuity. So for this function, it was discontinuous at x equals 1 because at 1, f is undefined. For the second example, I have the piecewise function 2x plus 1 when x is greater than 0, which is this portion of the graph, and x minus 1 when x is less than 0. And again, using the informal definition, if I come over to here, I have to lift my pencil off the paper in order to continue the function. So we're going to say that this graph is discontinuous. At x equals, in this case, x equals 0, and we have to have a reason. And the reason why it's discontinuous is because the limit, the two-sided limit, as x approaches 0 of f of x does not exist. So the second reason that a graph can be discontinuous is because the limit at the point that I'm looking at, the limit does not exist. The final reason that a graph can be discontinuous is exemplified by this piecewise function. We have x squared minus 1 over x minus 1, which is this portion from the original function I showed you. And when x is 1, this is 3. Okay, and again, this graph is discontinuous. Using the informal definition, because once I get to 1, I've got to jump up there, fill in the dot, come back, and then fill it in, so I have to lift the pencil off the paper. It's discontinuous at x equals 1, and the reason why is, if you look here, this 3, if I were to pull it down here and put it in the hole, it would be continuous. Well, it's because, it's because this point right here does not actually reflect the limit as I approach 1 from the left and the right. So the reason we're going to use f of x is discontinuous at x equals 1 because f of 1 does not equal the limit as x approaches 1 of f of x. So we've seen 3 different reasons for a graph to be continuous. The first reason that a graph can be discontinuous is if at a point the graph is undefined. The second place that a graph can be discontinuous is because the limit of a function at a particular point does not exist. And the final way that a graph can be discontinuous is if the actual value of the function does not equal the limit of the function. So now we will come up with the formal definition of a graph being continuous at a point. For a graph to be continuous at a point at, we'll call it point A, f of A must be defined. The second condition is that the limit as x approaches a, again this is a two-sided limit, of f of x must exist. And the final condition is that the limit as x approaches a of f of x must equal the value of f of a. And again, you can use the informal definition to analyze your graph, whether or not it's going to be continuous at a particular point. But you must give me a reason that uses one of these three things if it is discontinuous to tell me why it's discontinuous.